Before we begin the actual nomenclature or naming of compounds, we actually need to identify the type of compounds we have. So in previous videos I explained that you have a positive part, which is called the cation, and it's always good to know what your cations can be. And we have a negative part, which is the anion. Okay? So just like in the previous video, whenever we have metal, which is a cation, we can mix it with different types of anions, but these are not all the chemical family types, but they're most of them. So another one can be cation is also hydrogen, which is always going to be +1 when it's acting as a cation. And the last one we're going to analyze is nonmetals, which include metalloids, which also have positive charge but in different measure. When we speak about anions, we can also speak about nonmetals, which include metalloids, of course with a negative charge. We can speak about oxyanions, which I will speak about in another video. We also speak about oxygen independently. We speak about hydrogen independently. And there's a fourth one, which is hydroxides, which also fits, but we're going to leave it on the side right now because it's pretty easy to identify. So this is just a quick video so that we identify the different types of chemical families. Whenever our cation is a metal and the nonmetal becomes the anion, the type of family we're going to have is haloid salt, which is also called binary salt. Quick example of this would be something like, let me think one off the top of my head. Well, the simplest one actually, metal, sodium, nonmetal, chlorine. So, sodium chloride. Whenever we have a metal cation and an oxyanion, we have something called an oxy salt. And oxy salts are characterized, again, by having a metal. Let's choose something like, I don't know, magnesium, which has a +2 charge, and then the oxyanion is SO4. SO4 represents sulfate, so magnesium sulfate is an example of this. Next, when the cation is a metal and then the anion is oxygen, we're going to get something called oxides or metallic oxides. And these are very simple, and I'm going to do the most traditional one, iron. So for example, iron is +2, oxygen is always -2, and we're going to get iron 2 oxide, okay? Which I will explain further on in another video, how to name them properly. Last but not least, when we have metals with hydrogen as an anion, we call these hydrides. And these are easy to identify, again, because we have a metal, for example, potassium, and hydrogen as an anion is always -1, so we get potassium hydride is an example. Now, if we go further down, or I'll make some room for that at the end, don't worry about it. When we go down the table, let's speak about, for example, hydrogen as a cation. Hydrogen as a cation is always going to be +1. And when we mix it with a non-metallic anion, we're going to get something called a hydracid or a binary acid. Why binary? Because it's only made up of 2 different types of elements. And a very simple example of this would be hydrogen first, which is the cation, with chlorine, hydrochloric acid, which is pretty standard in most labs, okay? Hydrochloric acid, or maybe even hydrosulfuric acid, H2S. Why? Because sulfur is -2, so we do the crisscross and H gets 2 atoms. We need 2 atoms to do the electroneutral compound. Whenever we have hydrogen as a cation and then we mix it with an oxyanion, you're going to get something called an oxy acid. And oxy acids, again, are recognized because we have hydrogen as a cation, which is always +1, and then we get an oxyanion. So for example, here, sulfate is -2. So since this is -2, when we do the crisscross, H2SO4, sulfuric acid, which is also pretty standard. Okay? Naturally, if we mix hydrogen and oxygen, we're going to get water. And if we mix hydrogen with hydrogen, we're going to get hydrogen gas. So these are other things that this is pure elemental hydrogen, this is water. Water is universal, so it has many different functions of the other chemical families. And in the last column, when we speak about a nonmetal with a nonmetal, that means that the cation is nonmetallic and that the anion is nonmetallic, we're going to get covalent compounds. And covalent compounds, the example would be right off the top of my head, carbon, which is +4 when it's a cation, chlorine, which is -1. We do the crisscross, 4 goes here, 1 goes here, and we get carbon tetrachloride, for example. Okay? Then, so that I don't confuse you anymore, we're not going to do this one. Doesn't apply. Nonmetal with oxyanions, no. And nonmetals with hydrogen, we're not going to talk about that right now. It's not relevant to the subject. But last but not least, what is relevant is when we have a nonmetal cation with oxygen, we get something called anhydrides. Hydrides, which are essentially non-metallic oxides. And a very simple example would be the world famous carbon dioxide, carbon oxide, or maybe even, let me think, something with phosphorus. So phosphorus can be, in its valence, can be +5. So we can have diphosphorus pentoxide as an example. And the basic tip here is always analyze what your cation is, what your anion is, and where they cross, it's the type of family you're going to get. And it's that simple. And the last thing I was going to explain is if you have a metal and another anion which is OH, which is hydroxide, what do you get? We're going to get, this is hydroxide. And the chemical family is, just as the anion name is hydroxide. And a simple example would be lithium hydroxide. And in further videos, we're going to see the naming style for each of these families so that you can practice and do some exercises. Thanks.